Okay, hello friends. So let's try putting all we were here in the last video trying to add and subtract some of these terms together. So you know what gives. Okay, let's combine these things into a single fraction. Then we can continue, right? Now of course if you find this part boring, you can just skip ahead to the end of the video. Okay, I won't blame you for that. Okay, so first thing first, I want to make all the denominators the same. Okay, I want to make all the denominator parts the same. So this is what I'll be doing. So the first term here, I will just multiply top and bottom by whatever the denominator of both of these are. And you can guess it's going to be a big cancel fest. So you're going to cancel a lot of terms. So yeah. And before continue, before I start multiplying things in, let's just cancel the 2 off here and here, because it's going to save us a little bit of trouble if we can get rid of things early. So I'm going to use this number 2 to get rid of this number 2's here. Or rather, I'll... How do I put this? Yeah, let me get rid of this number 2 and this number 2's over here, just to make life easier. Okay, because let's see. Okay, maybe, never mind. I don't want to do that yet. I'll use this number 2 to cancel out these two things. Or maybe not. Yeah, I'll do the cancelling out later. I'll just see what's a good common denominator for everyone to have. Okay. And these things we'll need to do the same as well. We'll need to get this 2 multiplier there, top and bottom, which kind of is a little bit redundant to me, but okay. Let's just do it. We have a 4 to the top and 2 at the bottom. And let's take this term here, multiply it to the top and bottom. Like this, we have all the same denominator. Okay, last but not least, we'll do the same for the last what do you call it? The last one. Very messy, but I mean, I apologize, we have to do this. Okay, 2 delta t plus delta p plus delta p. Okay, and we can just multiply that to the top. Okay, hopefully this makes our life, you know, slightly easier, but you know, things are never easy like that, you know. Okay, let's do a big fraction, and then I will just put all of this in the denominator into one long term, and all the stuff at the top I'll just also put together. Okay, we have a minus whatever's found in the second term. Okay, plus what else is found in the third term. Okay. Okay. So now let's see whether we can make life easier for ourselves by cancelling out some of the 2's. Okay, now I think the cancelling makes sense. Let's get rid of the 2's. Okay. So I'm going to divide top and bottom by 2. So this thing I will cancel out in the first term. I'll just divide it by 2. Second term here, we'll just cancel these 2 things out here by 2. 1 here, 1 here. And the last term, we'll also cancel out by 2. Cancel out by factor of 2. Did I forget something? Oh yeah. So 2 on top, 2 on bottom. Yeah, I think I forgot a 2 delta t over here. Okay, 2 delta t. Okay. Okay, this should be 2 delta t. And yeah, okay. Now that looks more legit. And this last one here should also have a 2 delta t. Okay, there's 2 delta t plus delta p, and then it should also be in the numerator. Okay. Okay. But that does mean we need to take away this other number 2. Okay, because you divide top and bottom by 2. Okay, not too bad. Now, let's make life easier again. To make life easier, we introduce this ratio. Okay, again, this is from the textbook. Okay, remember we're talking about the ratio of the boundary layer thickness. There's some function of the Prandtl number. Okay, where is it? Yeah. Yeah, this term. Yeah, dp over dt is equals to some function of the Prandtl number. So we like to call this thing for high Prandtl number fluids anyway. Delta t over delta p over delta t. Okay. So that's our ratio for relatively high Prandtl number fluids. So what are we going to do? Okay, we are going to divide top and bottom by delta t so that we can introduce this q in. Okay, top and bottom by delta t. How much time do I have? Okay, I'm still at 9 minutes. Good time. Okay. So I'm not just going to do it once, I'm going to do it twice, okay? I'm going to do it twice. Why am I doing it twice? So that because there are lots of times we are multiplying delta t and delta p. So let's do the denominator first. So one of the times we used to do this delta t, this will be here. You'll divide this term here by delta t, and you'll divide this term here by delta t. So that will just become q. Okay. So this is the first time we are doing it. So let's do a 2 plus q thing at the top here as well. 2 plus q on top. Here we can just knock off one of these delta t's. Very simple. Here we also have one of these delta t's which we want to take out. So that's the first time. So yeah, that's one. And we'll do it a second time. We'll do it a second time as well. This time we'll mess around with this term here. Okay, so delta t divided by delta t become 1. The delta p divided by delta t becomes q. Okay, so now it looks less alien, and a lot less alien. So this becomes 1 plus q, this becomes 1 plus q. 1 plus q. Okay. Then the last one will be this 2t plus q, 2 delta t plus q, which will become 2 plus q. Okay. Okay, so now with this, I think can breathe a little bit easier. We have a nice short, succinct denominator. We can actually just factorize out this delta p out to the front. Yeah. Okay. Pardon me that I didn't use the same capital and non-capital delta p. They kind of mean the same thing, essentially. I'm just a bit stuck on the space bar. Yeah. Okay, so now okay. So yeah, let's do some multiplication. Or you know what? Let's just let Wolfram do everything. 2 plus x. Okay, 2 plus x. 1 plus x minus what? 4. 1 plus x plus 2 plus x plus 2 plus x. Okay, let Wolfram do everything because I don't want to do any more work. Okay. Okay, great. It's not very helpful. Yeah, ideally this thing should actually reduce down reduce our equation down very much. Yeah. Hold on. Okay, so anyway, I just rewrote this thing here for to be 2 times 2 so that you can see the transition a bit easier. Okay. Anyway, I think we can look back at the Wolfram. Oh, let's just say the alternate form here is x squared, or in our terms is q squared. Okay? It's just x squared. Okay? Alright. So yeah, we do have a good form. So no careless mistakes there, thankfully. So this part of the numerator is just, we'll just have q squared on top. And then 2 times 2 plus q, 1 plus q at the bottom. Okay, thank God for Wolfram. Okay, so let's substitute this back into the integral. Okay, the integral, this very messy integral. Okay, substitute into integral. And this whole bracket, we can just we know what's inside the bracket. Okay, Okay, the vy square is on the outside. What's inside the bracket? It's this whole thing which we're trying to evaluate. Okay, which kind of nicely turns into just this very neat expression, delta p. Okay, q square over this whatever it is here. Okay, so that's what we spent the last 20 minutes ish doing. 15 minutes. Okay, so okay, now it can breathe a little easier. And substitute this back into the equation. Back into equation. And where's this equation? Okay, the momentum equation. Momentum equation first. Okay, so this is the one. Okay, so this thing is a bit hard to differentiate because I don't even know how all of these actually change with y. Like q and delta p and vy, all of this, I don't know how they change with y. So we'll just leave them in the so-called non-explicit form, which is implicit form. Oh my goodness, yeah, we'll just do that. Left bracket, paste, right bracket. Okay, now I really hope that the other things are a little more palatable. So let me put all of these on top just to save space. Okay, this is just to get all the left hand side stuff, which I do apologize, it's very tedious. Okay, so now let's do del v del x. Okay, let's do the viscosity term. Okay, which is a wall shear stress. Okay, fraction partial v partial x at v equals to 0. But let's just differentiate that one first. So we'll need to differentiate all of this. Partial by partial x. Differentiate all of this. Okay. Okay, so that's one. First thing first, we can bring the y out. The vy term out, because that's only dependent on y. Okay. And then I don't really feel like doing a product rule thing, so I'll just multiply this. I'll multiply this in straight away. Okay. And I seem to not have properly put in my parentheses. Okay, so we can easily differentiate this first term, and this second term we'll just add the powers together. One, two, and third bracket. Okay. Okay, so now yes, we can do that. let's start differentiating. And to differentiate, this is pretty simple. I'm just gonna take out the partial by partial x. Now I have the fraction minus 1 over delta p outside here. And I'll have that okay, fraction minus 1. Okay, so this will be delta t plus delta p divided by delta t delta p. All right. Okay, so now let's me yeah, I just quickly like combine these fractions together. So I didn't really yeah, do it a little as rigorously, but okay, should not be a problem. Yeah, exponentials, I will leave them alone. Over here, and this minus sign will go to the front. Okay. Okay. So now let me take out that one because it's an eyesore. It's not needed anymore. Okay, now evaluate at x equals to 0, which is again great news because most of the terms will just drop off. Most of the terms will just drop off. Okay, so the exponentials will become 1. And our life will be a lot somewhat easier. Yes. Okay. So how do we deal with this? Okay, for the second term, I'm going to try dividing the top and bottom again by delta t, so that we can get our 1 plus q kind of a form. Okay, I'm going to divide top, or rather, yeah, divide top and bottom by delta p. And the top will be, okay, 1 plus q. 1 plus q. Okay, so this is convenient. It will just reduce everything down to q over delta p. Alright, wow, that was a lot easier than the first one. So let me put the vy there. Yeah, put the vy there. Now we can substitute back in, and I think I'll just call it a day. Call it a video. I'll end this video. So back. Okay, so this term will just go in here. I'll go into the second one. And of course the third one will be how we differentiate this or integrate the temperature profile. Okay, so I'll talk about that in the next video. Thanks for watching. I'll see you again. Goodbye. Okay.